Hi students, I just want to give a quick notes on the atom for you today. Alright, so we're in our new chemistry unit, right? And we just finished talking about what matter is, right? And matter is anything that takes up space and has volume. We looked at the different states of matter, and we looked at physical and chemical properties of matter, as well as changes, right? How we can change matter both physically and chemically. So now we're going to look at what makes matter up, and that would be atoms. Okay, so the word atom comes from the Greek word atomos, which means something that cannot be divided any further. That means it's the smallest part of all matter. An atom is the smallest particle of an element, means we can bond it together with other atoms to make bigger things, which is why some things we have to look under a microscope and some things we can see with our eyes, right? An atom is really tiny, but when you put a bunch of them together, it can make large amounts of matter that we can actually see. An element is matter that is composed of only one type of atom. And we're going to talk about elements in a little bit. We looked at the periodic table of elements before, but that's what we mean by an atom. So if you look at your periodic table and you see hydrogen or helium, one of those is a single atom. And only hydrogen is hydrogen. No other atom can be hydrogen except hydrogen. So that's what we mean by an element. An element is one type of atom that has properties that are unique to itself. And again, atoms are the building blocks of molecules and all matter. So let's watch a short video on atoms real quick.
Hi, I'm Emerald Robinson. In this What Is video, we're going to take a closer look at atoms. All matter is made of elements, substances that cannot be broken down by chemical activity. An atom is the smallest particle of an element that retains the element's properties. Atoms are the building blocks for everything in the universe, including ourselves. People often think of atoms as the smallest possible forms of matter, but even smaller particles make up atoms. Each atom has a dense center called a nucleus. The nucleus contains neutrons, which have a neutral electric charge, and protons, which are positively charged. The number of protons in an atom determines an element's physical properties. No two elements have the same number of protons. Revolving around the nucleus like planets around the sun are negatively charged particles called electrons. Electrons and protons attract each other, so atoms usually have equal numbers of the two particles. Scientists assign atoms an atomic number and atomic mass unit. The atomic number is the number of protons present in the atom. For instance, a helium atom has 2 protons, so helium's atomic number is 2. Add the number of protons and neutrons in an atom's nucleus together, and you get the atomic mass unit, or AMU. A helium atom has 2 protons and 2 neutrons, so has a mass of 4 AMU. Electrons have almost no mass and are not included in AMU calculations. While an atom's number of protons remains constant, individual atoms can lose or gain electrons. Atoms with different ratios of electrons to protons are called ions. Atoms of the same element can also have extra neutrons. Scientists call atoms with extra neutrons isotopes. Despite having different neutron counts, isotopes retain their element's chemical properties because the number of protons remains constant.
Okay, so atoms have 3 subatomic particles that we just saw in the video. And a subatomic particle, it's going to look here, means really small. These are the particles that make up atoms. So atoms make up matter. Subatomic particles make up atoms. So we have protons, which we say is positive. That is our symbol for positive, this plus. Right, so if we point in this atom, it seems like our atom here has 3 protons, right? Because I'm looking for those that positive symbol on there. Neutrons have no charge, they're neutral, right? 0. So I'm going to look for particles that don't have any symbol on them at all. So if I look at this one here, I'm just going to change my pen color to make this a little bit easier, right? I see that these particles here have no charge on them. They have nothing written on them. They're blank. So those are going to be my neutrons. They're neutral. And my electrons are negative. So let's take a look at our electrons here, right? So this is the symbol, this minus sign means negative. Right? And it looks like I have 3 electrons on there. Now, if we were in class, I would ask you, what do you notice about the ratios of these? And you would see, if you were counting them, that I have 3 protons, I have 4 neutrons, and I have 3 electrons. And if we were to look at multiple atoms, we would see this always be true in a regular atom on our periodic table, that our protons and our electrons equal each other. And that's where these symbols are important. That's because positives and negatives cancel each other out. So if I have 3 positives and I have 3 negatives, just like if in math, if you had a positive 3 minus 3, right, you would have 0, right? And that's important because when atoms don't equal 0, if they were to have more or less electrons, they would interact with each other because your positive and negative charges attract one another. So this is important, this idea of what we call being neutral. Okay, that your protons and your electrons equal each other in an atom. Okay, so one more thing, your protons and neutrons are located in what we call the atom's nucleus, this center part. Nucleus means, specifically, I'm going to change my color again. Right, it means like the heart. I think it actually means kernel. I want to say that that's the actual literal translation of it. Kernel, like a corn kernel, like a little piece of popcorn, right? Or the heart. So we call this centerpiece here the nucleus, right? Or the heart of the atom. That's where your protons and neutrons hang out. And they make up the mass, right? So if you were to step on a scale in your house, right, your mass would come up, right? Whatever that is in kilograms or pounds. If you were to weigh an atom, the nucleus is where all its mass is. These protons and neutrons are heavy, and they make up that heart of the atom, which gives it weight. Around it are electrons, these ones that are moving around the nucleus. They have no weight at all. I mean, they're not invisible. They have a little bit of mass, but it's so minuscule that it doesn't even affect the mass of the entire atom. So they're really tiny, but their job, as we talked about before, was to cancel out the positive charge of those protons, right? And that's why your protons and electrons equal each other. So we call that path, looks almost like a solar system, right, that they're kind of orbiting around. We call that the electron orbit. And to orbit, that's a new word, right, means to circle, right? They stay on that path and they just circle around the nucleus. Okay, so the number of protons an atom has determines the atomic number or chemical element. So I'm going to pop to this slide and then we're going to go back to that one. So what does that mean, right? The number of protons determines the atomic number. So here's our periodic table. And if you notice, there's numbers written in the left-hand corner. And it goes in order. Hydrogen is 1, helium is 2, lithium is 3, beryllium is 4, 5, 6, 7, 8. That's not random. That is the protons in that atom, right? So that means if you are boron, you have 5 protons. Nobody else but boron has 5 protons. Because if you have 4 protons, you're beryllium. And if you have 6 protons, you're carbon. So your protons, it's like your name, right? It's your identity if you're an atom. It tells you exactly who you are. So your proton is really important. And that's our first introduction to the periodic table. And that's that our elements are arranged by the number of protons they have. That's what that number means. We're going to learn what these other numbers are, as well as the symbols that are around them a little bit later. But right now, all I want you to know is that this number in the left-hand corner is the number of protons, and we call that the atomic number. And that's how our periodic table is arranged, by our atomic number. So that's why protons are important. Now electrons, we said that they don't have any mass. So what's their job, right, besides being the opposite of a proton? Well, they define the atom's chemical properties. That means, you know, why does water react the way it does? Why does hydrogen gas do? Why do molecules? Why does anything act like it does? I did the experiment for you where I mixed the baking soda and the vinegar. How come that happened? Well, it has to do with the electrons, right? These determine the chemical properties of elements and compounds. And that's why they're important. So protons determine what an atom is. Electrons determine what an atom does. Okay, so the flow of electrons from one atom to another is called electricity. That's where electricity comes from. When you have positive and negative charges like that, energy flows between there and we get electricity. We can also get magnetism, right? And we call those electromagnetic fields. Electromagnetic fields. Okay, you might have also heard the term, radiation, all the same idea. Right, but atoms are made up of mostly empty space. So I want to end this lecture on a very cool video that's going to show you just how small atoms are, but how inside they're almost nothing at all. They're mostly empty space, including us. If you were to look at what we humans, all matter, are made out of, it's almost nothing. Anywhere you look, it's empty space. Okay, approximately 1 million atoms can fit on the tip of a pin. That's how tiny they are. So let's end with this video here.
Probably already know that everything is made up of little tiny things called atoms. You might even know that each atom is made up of even smaller particles called protons, neutrons, and electrons. And you've probably heard that atoms are small. But I'll bet you haven't ever thought about how small atoms really are. Well, the answer is that they are really, really, really small. So you ask, just how small are atoms? Well, to understand this, let's ask this question. How many atoms are in a grapefruit? Well, let's assume that the grapefruit is made up of only nitrogen atoms, which isn't at all true, but there are nitrogen atoms in a grapefruit. Well, to help you visualize this, let's blow up each of the atoms to the size of a blueberry. And then how big would the grapefruit have to be? It would have to be the same size of, well, actually, the Earth. That's crazy. You mean to say that if I filled the Earth with blueberries, I would have the same number of nitrogen atoms as a grapefruit? That's right. So how big's the atom? It's really, 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 really small. And you know what? It gets even more crazy. Let's now look inside of each atom. That's the blueberry, right? What do you see there? In the center of the atom is something called the nucleus, which contains protons and neutrons. And on the outside, you'd see electrons. So how big is the nucleus? Well, if atoms are like blueberries in the Earth, how big would the nucleus be? You might remember the old pictures of the atom from your science class where you saw this tiny dot on the page with an arrow pointing to the nucleus. Well, those pictures, well, they're not drawn to scale, so they're kind of wrong. So how big is the nucleus? So if you popped open the blueberry and were searching for the nucleus, you know what? It would be invisible. It's too small to see. Okay, let's blow up the atom, the blueberry, to the size of a house. So imagine a ball that is as tall as a two-story house. Let's look for the nucleus in the center of the atom. And you know what? It would just barely be visible. So to get our minds wrapped around how big the nucleus is, we need to blow up the blueberry up to the size of a football stadium. So imagine a ball the size of a football stadium, and right smack dab in the center of the atom, you would find the nucleus. And you could see it. And it would be the size of a small marble. And there's more. If I haven't blown your mind by now, let's consider the atom some more. It contains protons, neutrons, and electrons. The protons and